Hi, my name is Jenny Kopis. I'm an OTA student at Fox College, and in this video I'm going to be pointing out some key principles of movement while my fiance Mark is chopping wood. So I hope you guys enjoy it. Right off the bat, I see some changes we can make in order to reduce fatigue and promote safety within this activity. We can start by increasing the friction between his feet and the ground by wearing shoes that have a thicker tread. These happen to be steel-toed boots that add protection against the axe's blade. Another suggestion is to wear safety goggles to protect your eyes from pieces of wood flying off the log. It is also beneficial to put the log on a raised, stable surface to reduce fatigue and effort. The wood on the ground is harder to chop through due to the ground absorbing the shock needed to split the wood. This ultimately requires more effort from Mark to get the job done. By raising the work surface, we promote better body mechanics by reducing his need to bend at the waist. Mark's center of gravity is normally in the center of his body, just below his belly button. However, since the axe increases mass, his center of gravity moves towards it. When the axe is overhead, the center of gravity moves superiorly, and when he moves the axe away from him, the center of gravity moves outside his body. Mark's base of support is his 2 feet planted on the ground. During the swing, we will notice his stance is wide and his left foot is slightly in front of the right to prepare for the forward movement of the axe. At the end of the clip, we see Mark put the axe on the ground and lean on it. By doing this, he is adding a 3rd base of support. Newton's law of acceleration is observable in this activity because the mass of the axe, along with the force of his muscles applied to it, is directly related to the rate of acceleration the axe will achieve. If he were to use a smaller axe, it would need much less force and he could swing it much faster. However, it would be much less effective when hitting the log. When chopping wood with an axe, we are also using a simple machine called a wedge. When the axe meets the log, its wedge shape deflects the downward force into a lateral force and pushes the wood apart. The shoulder's glenohumeral joint is a type of synovial joint classified as a ball and socket. It is triaxial, which allows 3 degrees of freedom and a combination of movements. When Mark moves the axe back, we see his left shoulder go into horizontal adduction, while the right externally rotates. Both of these movements occur in the transverse plane on a vertical axis. Horizontal adduction has around 130 degrees range of motion, while the external rotation typically has around 90 degrees range of motion. Next, he moves the axe up over his head, and we see his left arm move into shoulder flexion, while the right shoulder abducts. Shoulder flexion occurs on the sagittal plane on a frontal axis and allows for about 100 degrees range of motion. Abduction occurs in the frontal plane on a sagittal axis and has about 120 degrees range of motion. As Mark moves the axe towards the log, both shoulders move from a flexed position towards extension, which occurs in the sagittal plane on a frontal axis. If the wood was not there to stop the axe, his shoulders would have the ability to go into full extension behind the body with about 45 degrees range of motion. Because of its complex nature, chopping wood requires a manual muscle grade of 5 since full range of motion must be achieved despite the full weight of the axe.